If you've ever heard the phrase God particle, it probably sounded like something straight out of science fiction, something mysterious, powerful, maybe even supernatural. But despite the dramatic nickname, the so-called God particle is actually a very real and very important piece of modern physics. It's not divine and it doesn't control the universe, but it does help explain why anything in the universe has mass at all. Without it, atoms wouldn't form, stars wouldn't exist, and you definitely wouldn't be watching this video. So what exactly is this particle? And why did it take decades and billions of dollars to find it? So let's break it all down, right here, on History of Simple Things. The story begins in the 1960s, when physicists were trying to make sense of how fundamental particles behave. At the time, scientists were developing what we now call the Standard Model of Particle Physics, a framework describing the basic building blocks of matter and the forces acting between them. The equations worked well, except for one big problem: they couldn't explain why particles have mass. In 1964, a physicist named Peter Higgs and several others proposed a solution. They suggested that an invisible field exists everywhere in the universe. This field, now called the Higgs field, interacts with particles and gives them mass. To prove that this field exists, there must also be a particle associated with it, the Higgs boson. For decades, this particle remained purely theoretical. It became one of the most sought-after discoveries in physics, leading to the construction of massive experiments designed to find it. Let's clear up the nickname first. The term God particle wasn't invented by scientists. It actually came from a popular science book by Leon Lederman. He originally wanted to call it the goddamn particle because it was so difficult to detect, but the publisher shortened it. The name stuck, even though many physicists don't like it. So, what is it really? The Higgs boson is a fundamental particle, meaning it isn't made up of anything smaller. Its importance comes from its connection to the Higgs field. Imagine the universe filled with an invisible substance. As particles move through it, some glide easily while others get slowed down. That resistance is what we perceive as mass. In simple terms, the Higgs boson is evidence that this field exists. Detecting the particle is like seeing ripples in water. It tells you the water is there, even if you can't see the whole ocean directly. Mass might sound like a basic concept, but it's actually fundamental to everything we experience. Without mass, particles would move at the speed of light and never stick together. That means no atoms, no molecules, no planets, and no life. The Higgs field gives different particles different amounts of mass. For example, electrons are very light, while particles like top quarks are extremely heavy. The reason for this difference is still not fully understood, but the Higgs mechanism explains how mass itself is possible in the first place. It's important to note that the Higgs boson doesn't give all mass in the universe. Most of the mass of everyday objects, like protons and neutrons, actually comes from the energy of the strong nuclear force. But without the Higgs field, even those particles wouldn't exist in a stable form. Finding the Higgs boson wasn't easy, because it's extremely unstable. It exists for only a tiny fraction of a second before decaying into other particles. Scientists had to recreate the conditions of the early universe to detect it. This is where CERN comes in. Located near Geneva, it houses the world's largest and most powerful particle accelerator, the Large Hadron Collider, or LHC. Inside the LHC, protons are accelerated to near the speed of light and smashed together. These high-energy collisions can produce rare particles, including the Higgs boson. Detectors then analyze the debris to identify patterns that match theoretical predictions. After years of experiments and data analysis, scientists finally made a breakthrough. On July 4, 2012, researchers at CERN announced they had discovered a new particle consistent with the Higgs boson. It was a historic moment in science, one that confirmed a theory proposed nearly 50 years earlier. The discovery wasn't just about finding a particle. It validated a crucial part of the Standard Model and deepened our understanding of how the universe works. In 2013, Peter Higgs and François Englert were awarded the Nobel Prize in Physics for their contributions. Even today, scientists continue studying the Higgs boson to learn more about its properties. Any unusual behavior could hint at new physics beyond what we currently understand. You might be wondering, why should any of this matter to everyday life? After all, we don't see Higgs bosons in daily experience. The answer is that discoveries like this shape our understanding of reality at the deepest level. They help answer fundamental questions. Why does anything exist? Why do particles have the properties they do? And is our current model of physics complete? The Higgs boson could also open doors to new discoveries, such as insights into dark matter or extra dimensions. It's not the end of the story, it's just one piece of a much larger puzzle. So, the God particle isn't a mystical object controlling the universe. It's a key to understanding why the universe exists in the form we see today. The Higgs boson represents decades of human curiosity, collaboration, and persistence. From a bold idea in the 1960s to a groundbreaking discovery in 2012, it shows just how far science can go when we ask the right questions. And who knows, the next big discovery might already be hiding in the data, waiting for someone to find it. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.